Hi, everyone. My name is Karina. I am here to talk to you about Kentik Cube. So Kentik is a network management platform company that provides visibility, performance, and security services to digital enterprises. And part of what Kentik does is focus on showing the flow of network traffic through cloud infrastructure and cube resources. So that's what I'm going to talk about today. Our product, Kentik Cube, which I'm the product manager of, shows customers how network traffic routes through the data center, the cloud, and the internet, and all the Kubernetes resources. So network observability for cloud, basically, the way we do things at Kentik is that we don't know what questions necessarily our customers will have about so what we do is we try to use the Kentik data engine to provide a lot of powerful data about our customers' cloud and our customers' application contexts and all their networking information to make the data as meaningful as possible, process as much metadata as we can, and just give them all the tools to create the alerts that they need and utilize the information in a way that they need. So here, this is basically an overview of how Kentik's network observability platform works. The left side is basically the data coming in, all the networking data, and then Kentik ingests all the data from these various sources, like these different clouds and these different devices and vendors, and makes these tools available for customers, like powerful APIs, flexible queries, various insights to let customers build the tools that they need. So our focus is on enterprise, and this is some data that is available that's derived from Kentik's customer service data. So for Kentik Cube is basically a tool that allows cloud and infrastructure engineers to see network traffic to, from, and inside Kubernetes clusters. So the purpose is to give performance visibility so that users can easily view and fix network problems in their Kubernetes cluster. So if you can see this image, you are able to see basically all of your Kubernetes clusters in relation to one another, and then also the rest of your cloud, your on-prem infrastructure, and the traffic coming in from the internet. So Kentik Cube supports cloud-managed Kubernetes clusters like AKS, EKS, and GKS, as well as on-prem self-managed clusters. And it's meant to work for hybrid and multi-cloud. So the way it's set up is that there is like a topology map to view the Kubernetes infrastructure and also the flow of traffic between the Kubernetes resources, the internet, and whatever other infrastructure you have. And that gives kind of a bird's eye view, and it also makes it possible for the user to see if the network reality matches the policies that they've set for their various Kubernetes resources. And it's possible to create alerts for performance issues, like, for example, create an alert if a service has a certain amount of latency, and also see traffic coming in from the internet. So for example, you can track if traffic is coming from non-compliant areas and take action. So one such use case using Kentik Cube is just to see what Kubernetes resources are experiencing network delays, like specific services, specific deployments, identify misconfigurations easily and quickly with a bird's eye view, and configure alert policies, and just check policy validation. So in this image, this is a Kubernetes cluster running in AWS, and the various red pods over here are just, different pods that are experiencing a certain amount of latency. This is for one of our clients. So then the tab on the right, this will be much, much more clear in the demo, by the way. It's possible to kind of see the map of the latency and create alerts on it. So another use case using Kentik Cube is to determine top talkers from the internet. So kind of identify clients and requesters that are consuming Kubernetes resources and track down problematic connections or certain customers from the internet that are may not have authorization to access the resources they're accessing, maybe contributing an unexpected amount of traffic and oversubscribing to certain microservices. So then the user can take action, adjust policies, try to figure out what's going on, adjust resources as needed. And another use case is just being able to visualize the entire network infrastructure. So, we always say it's viewing the network from container to cloud, just being able to visualize the network traffic and, see which Kubernetes resources are communicating with non-Kubernetes infrastructure. So some background on how Kentik Cube actually works internally, now that we've talked a little bit about the UI and about how users can utilize the tool. The way Kentik Cube actually works in the cluster is that it relies on a data generated from a lightweight eBPF agent called Kappa that is installed in the Kubernetes clusters. So eBPF is a kernel technology that improves observability, networking, and security in the Linux kernel. And the data from that agent is sent to Kentik, and basically it allows the customer to query, graph, and alert on various conditions in the Kubernetes cluster. And the image is kind of a few graphs and maps based on some of the data gathered by Kappa and processed by Kentik. So a bit of an overview on how Kappa works. Basically, it's a very efficient tool for observability, and it helps to understand traffic flows from all kinds of different vantage points. It helps customers find congestion and performance hotspots, helps identify application dependencies, and it helps perform network forensics. So it's just a very useful tool to get a lot of information on the cluster. So here is a diagram to help understand a little bit more how the Kappa agent works. It is deployed on the cluster, and these dotted lines just show the various data sources that send info to Kappa. So they're the networking interfaces, there's the kernel information, and Kappa just takes the packets and it also takes in data from the Kubernetes API, data from the Linux kernel, and we are able to take all that information at Kentik and enrich flow data and use that data to create the Kentik Cube UI with all this information combined. So that allows the users to better patch their root cause analysis for cluster problems due to networking. And it's also a very small, lightweight, or Kappa is a small, lightweight, fast, and safe tool. So Kappa generates the kernel flow data using eBPF. So with that information, Kentik is able to see the total traffic passing through any source and destination IP, basically every conversation taking place within a host, cluster, or data center. And because this information is generated using the Linux kernel, Kappa also reports performance characteristics such as session latency and TCP retransmit statistics. Kappa also enriches these flow summaries with application context. So like, it associates conversations with process name, PID, command line syntax, and if a process is running inside a container, then the container name and ID are also associated. And if the container was scheduled by Kubernetes, then Kappa will enrich the flow data with all of the information associated with the Kubernetes resource, like the name, the namespace, the node identifiers. So Kappa is able to look for records and join source and destination traffic records to show application communication within the data center and kind of show like the complete picture of application communications within a data center. So some advantages to the way that this tool is implemented are that it's an easy, flexible deployment. In contrast to application monitoring, Kappa is flow-based, so it runs with no changes to the application code. It's very easy to deploy, and it enables us to start monitoring infrastructure within minutes. It's a versatile single agent. It seamlessly covers a lot of different situations where traffic needs to be monitored. It has low resource utilization. It uses virtually no resources because it's built on eBPF, which allows sandbox programs to run within operating system kernel. It's built on the Kentik platform. So it sends its data to the Kentik data engine, which, then it's further enriched with all kinds of data, including threat, geolocation, internet context. And there are just a lot of advanced analytics included because Kentik offers a lot of rich visualizations, APIs, a lot of information to understand network utilization, performance, vulnerabilities, which really help to understand the unusual and unexpected patterns in traffic. So with all that information, Kappa allows users or Kappa generates metrics and dimensions, and the value of these are stored on the Kentik data engine and used for queries by customers. So there are all kinds of different parameters, and these are all different values that can be used when creating different alerts. So let me go into the demo. So the demo here is going to start in a tool called Kentik Map. And the way that it works is Kentik Cube is kind of a continuation of Kentik Map. And Kentik Cube, as you can see, or Kentik Map, shows the flow of information between, like, it shows the flow of information between all these different resources. And is the video blank? Yeah, it shows the flow of information between all these different resources in AWS, for example. And you can see that there are these different EKS clusters, and it's possible to show the connections. And once you click into an EKS cluster, it'll take you into Kentik Cube. And then once you're in Kentik Cube, you can view the different nodes and pods that are running in your Kubernetes clusters. You can view other infrastructure, and you can view also these different companies or these different agents sending traffic from the internet. And if you click a node or a resource, you can see traffic. And up in the corner over here, there is a list of issues found in all the different resources in Kubernetes. So if you click that, then it will show all the nodes and pods that are experiencing latency at that time. So then it's possible to click into one of those and see more information about what is experiencing an error at that time. And then once you do, then you are able to kind of see more information about performance, see more information about traffic, and then you are able to kind of click into something called Data Explorer, which allows you to create alerts. So once you get into Data Explorer, it's possible to view these various dimensions and narrow down based on what you want to filter by an alert on. So if you want to, create an alert on a certain type of resource, you can do that. And, at that point, it's possible to see a graph of, the historical information for that particular resource and create a necessary alert on that. So in this particular example, it's creating an alert on application latency.